In the last lesson, you learned about logarithms. Today, we're going to look at 3 properties of logarithms we can use to help simplify and evaluate expressions. We also want you to be able to use logarithmic equations or solve them using properties. So we know that logarithms are the inverse of exponentials. So some of those exponential properties you did before kind of go with logarithms here. So if you remember back when multiplying two monomial numbers where the base number is the same, here it's 3, we know that this would be equal to 3, and then what we do with the exponents is add them, and it'd be 3 to the 6th power, because 3 squared means 3 times 3. 3 to the 4th power means 3 times 3 times 3 times 3, 4 times, so you got a total of 6 of them. Okay, so if we apply that to logarithms, something very similar happens. If you have a log of two things being multiplied, that's the same as log, whatever the base is stays the same, of the first thing plus log with the same base of the second thing, 4. So it's log of 1 times the or log of 1 plus the other. And the reverse is too true. If you have two logs being added that have the same base, that's the same as log of the first thing times log of the second thing. So we would also know that what we have here is the same as log 3 of 2 times 4, which would be 8. So these would be equivalent. So we want you to be able to go both ways and use logs either way. One place this might show up is if you are asked to evaluate logarithms. Now, this one wants us to approximate what log base 4 of 6 is. Now, before in previous lesson, we showed you how you can do that on your calculator, and we'll review that right now. If you want to do this, you can go on your calculator, hit that math button, and then once you're to the math menu, if you keep scrolling down here, there is an option that says log base, and you can select that, and then you can type in 4 for the base, and you can type in 6 for the number you're taking the log of, and we see that this is equal to about approximately 1.29248 from there. Okay, so that's about what log 6 is, but here they want us to approximate it using other logs. This might come up on like a exam or something where maybe you can't use your calculator to do this and they want you to find it, or your calculator doesn't have that log base thing to do. So I know the military has a test called the ASVAB where there's a portion where you can't use the calculator. So we want you to be able to do it maybe if you didn't have a calculator too. So how you would have to do that is use log properties. Okay, we know that log of 6 here, another way of writing 6 is 2 times 3. 2 times 3 is the same as 6. So if we got two things being multiplied here, that means this would also be equal to, using our log property, log base 4 of 2 plus log base 4 of 3. So the two things being multiplied here would be the two numbers here. Now they tell us approximately what those are equal to. Log base 4 of 2 is equal to approximately 0.5, and log base 4 of 3, they tell us, is equal to approximately 0.79248, and if we add these together, it's equal to approximately 1.29248. Same result we got as when we plugged in the calculator. So that's a way you can use log properties to solve these out. One other thing to keep in mind when you are doing these log problems is anytime you have, say on this problem, we would have had something like log base 4 of 4. Now, even if they give you one of these and that one's not listed up here, like they didn't tell us what log base 4 of 4 is, but you should know that anytime the base number matches what you're taking the log of, that's always equal to 1. Just to show you that that's true, if you go in your calculator and type that in, log base 4 of 4, it always equals 1. Anytime the base number matches what you're taking the log of, it's always equal to that. Remember, common log is base 10, so if you do log base 10 of 10, that also equals 1. So anytime the base number matches what you're taking the log of, it's always 1. All right, let's try another one of those. This one wants us to figure out what's log base 2 of 48. Well, we got to try to figure out what's some numbers that go in to 48. Well, 48, if we make a little tree diagram here, two numbers that multiply to 48 would be 6 times 8. 6 is the same as 2 and 3, and 8's the same as 4 and 2, and then we know 4 also breaks into 2 and 2. So it looks like 48 is the same as 2 times 3 times 2 times 2 times 2. So we could write this out as log base 2 of all these things multiplied together. 2 times 2 times 2 times 2, 4 2's, and a 3. All right, that means we can split it into a bunch of logarithms the same way here. So we would have log base 2 of 2 plus log base 2 of 2 plus log base. We'd have all these logs here plus log base 2 of 3. Well, we know one of these here, this one, is equal to approximately the value they give here. And if you notice, all these match up, 2 and 2, 2 and 2, it's the same one. So all those ones are equal to 1. And this one's equal to approximately 1.5850. So it looks like the approximate value of this would be, if we add all those up, about 5.5850. That would be the approximate value. Okay, some other applications you can use this log property for would be to solve problems that look like this. Okay, so anytime you get one of these, what you're going to try to do is use some of those log properties to combine or separate the logs. So in this one, we have two logarithms here. On the same side of the equals, we are going to try to combine these together into a single logarithm. Okay, and when we do that, what it's going to look like then would be, since we got a plus right here, log base 4 of x times what we got here, x minus 6. So it'd be log of both of those things multiplied together. Okay, so now we got to keep solving this. Now, we can't just cross out this logarithm because there's not another one on the other side to cross it out with. So what we have to do next to solve this problem is get it out of log form and into exponential form. So what we need to do now is change from log to exponential form. Okay, and you did this before on previous lessons. What you want to do is leave alone what you're taking the log of. You're going to bring your base number over, in this case 4, and that's going to become the base of the exponent. Okay, so the base of our exponent is going to be 4, and then what's over here becomes our exponent. So that's going to be exponent of 2. Okay, so now that we got rid of the log by changing it to exponential form, this should be something we can solve. So now you just want to go through and solve it. Now this isn't a typical equation we look to solve a lot, but do what you know and see what you get. 4 squared, 4 times 4 is 16 on the right side. On the left side, it looks like we got some distributing we have to do. Okay, now we got to figure out how can we keep solving what we got here. We're not going to be able to add 6 and take the square root here because then we got an x on the right side we're trying to take the square root of. This looks like one of those quadratic problems that you did last trimester. So we need to get everything on the same side equal to 0. So the next step here would be to subtract 16 and get this one in standard form. Okay, now to finish the problem, we're going to try to figure out, okay, how do we factor this? What's going to multiply to negative 16 and add to negative 6? I think the two things that do that here are negative 8 and positive 2. They multiply to negative 16 and add to negative 6. Now use zero product property, put them both equal to 0, and solve it out. So if we put both these equal to 0, we get an answer of 8, and we also get an answer of negative 2. So now we got to figure out, well, which one's the solution? Are they both solutions? Are neither of them solutions? Is just one of them a solution? You got to plug it back in and see. So if we were to put 8 back in, I think we could do both of those because we would end up with log of 8, which we can do, and 8 minus 6 would end up being log of 2. That's another log we can do. We can do both of those logarithms. Let's check the other one, though. What if we put in negative 2? Can we do log of negative 2? No. If you remember, you can't do logs of negatives. Negative numbers are not in the domain of logs. So the only solution out of these two that works is x equals 8. That's the only answer that makes that true up there, because you can't do logs of negatives. All right, let's try another one of those. We want to solve this one out using log properties. Why don't you pause the video, try this one out, see if you can solve this on your own. All right, let's see how you did. We want to combine these with log properties. If we see a plus here, that means these are going to combine with multiplication. So it'll be x times x minus 12. Okay, now you got to change forms to exponent, change to exponential form. So it's going to be what we're taking the log of is going to equal the base number 8 to the power of 2, since 2 is on the right side. Now solve this out. On the right side here, we can distribute. It's going to be minus 12x. And then on the right side, 8 squared is 64. Get it equal to 0. In order to solve this, subtract 64. Now you got to factor it. What's going to multiply negative 64 add to 12? Looks like the combination that works here is negative 16 and positive 4. Do that. So if you put them both equal to 0 and solve, you're going to get an answer of 16 and negative 4. The only answer that works, however, is 16, because we can't do logs of negative if you plug that back in. So 16 would be the solution to that problem. Okay, so that's using the property that we listed at the beginning here. Whenever you're multiplying, that's the same as adding exponents. The reverse is true for logs. Another exponent property that we looked at is division. What happens when you divide with a common base? Well, we know that we should subtract the exponents. So this would be the same as 3 to the 4 minus 2 power, or 3 squared. Okay, so the reverse is true for logarithms. If you are dividing two things, okay, two numbers, that is the same as log of the top number, the numerator, 4 in this case, minus log of the same base of the denominator, what's being divided, 2. Okay, so that is another log property that we can use. So that would mean here that log base 3, since 4 divided by 2 is 2, is equal to that. All right, we're going to use that one. Let's do that one on a similar type problem that we did before, where they want you to approximate some log. So again, assume that you can't use your calculator, and they want you to evaluate what's log base 3 of 4. Well, we know by breaking down 4 that two numbers that divide to equal 4 would be 20 and 5. 20 divided by 5 is the same as 4. And the reason I picked 20 and 5 is that's the logs that they gave us here. Okay, so using log properties, that means if we got division, this is the same as log base 3 of 20 minus log base 3 of 5. Well, if we put the approximations in there, this one they tell us is approximately that. This one they tell us is approximately that. So let's put the approximations in. 2.7268 minus 1.4650. Now you just got to subtract those, use your calculator, whatever. Or if you weren't allowed to use the calculator, that's subtraction you should be able to do without. And you could figure out what the solution was, 1.2618. That's approximately what's it equal to. If you're not sure, like say you do have a calculator and they have one of these, you could definitely check it if you're able to do that. So find that math button, go to the log base, type in log base 3 of 4, and it should give us the same thing if we did it right. Yep, looks like the same number as what we got. All right, one more log property that we did is when you take a power to a power. When you take power to another power where this power is just hanging out, we want to multiply in this case. Because if you're squaring something like we are here, that means you got 3 to the 5th times another 3 to the 5th. Okay, which using the first log property we'd add, that'd be 3 to the 10th power. Well, a quicker way to do that is just to multiply 3 to the 10th power. Okay, reverse is true then of logs. If you have a power to another power here, that's the same as multiplication. So this is the same as 2, our exponent here, times log base 3 of 5. So anytime there's an exponent, what it allows you to do is take that number and multiply it to the log. That's how many times you're doing the log. And this is a very helpful property when doing logarithms. So let's do another one of those approximation ones. They want us to, on number 6, approximate this log. Well, if we have log base 4 of 36, we know another way of writing 36 would be 6 times 6, or we could write that as 6 squared. Well, using log properties, if there's an exponent, that means we're doing this 2 times. And since we're doing it 2 times here, we can just substitute in the approximation now and see what this equals. So this would be 2 times 1.2925, and if we times that by 2, looks like this should equal about 2.585. So that's how you can do approximation with exponents. Now this is a very helpful property when doing other problems too. So let's look at number 7. They want us to evaluate what this is going to equal. Well, if you see that there's a bunch of logs here, we want to try to combine and get as simplified as possible before we use any of the before we are able to kind of either solve by canceling logs out or changing it to exponential form. So if you look at this one first, it appears that this first log is being multiplied by 3. Okay, we can use that same property we just used, just in reverse. If this log is being times by 3, that means we could also say that that's an exponent of what we're taking the log of. So another way of writing this would be log base 5 of x to the 3rd power. Okay, now if we keep looking here, we got the same base log here, and we're subtracting. Okay, subtracting, we just talked about, is the same as division with logs. So this we could write out as log base 5 of whatever's first here, x cubed, divided by whatever second here, looks like 4. and that would be the equivalent of the 2 logs being subtracted. Okay, now when you're doing these problems and you get it down to this, where you just got 1 log on one side, 1 log on the other side, again, same base. If it's on the same side, you can just drop the logs out of the problem. So you get x cubed over 4 equals 16. If we can solve that now with algebra, we got the answer. Well, division, we got divided by 4 here. Let's do the opposite of division, times both sides by 4. Those then should cancel out. We got x cubed equals 16 times 4 is 64. Now we got to undo the power of 3. Okay, now when you're undoing power of 3, okay, it's going to be a root. Don't do square root though. Square root undoes power of 2. If we want to undo power of 3, we need to do cubed root. Undoes that. So on the left side, cubed root of x cubed is just x from what we did in previous lessons. Now we got to do cubed root of 64. You can do that on your calculator. We talked about using that math button, cubed roots on there, and then type in 64. And you see that the answer here comes out to be 4. So 4 is the answer. Now you should check, does that answer work? Yeah, if you plug that back into the original problem, we're not going to end up with logs of any negative numbers there. So 4 is the solution. All right, let's try another one of those. Number 8. We want to go through, do the same thing on here now. So any numbers that are in front of logs, we want to try to move those up as exponents. So it looks like that one we can make into an exponent there. That looks like the only one that had a number in front. So what we end up with is log base 2 of x to the 4th minus log base 2 of 5. Okay, now we want to combine down to a single logarithm on each side. We got subtraction. We know that subtraction is going to change to division. So it'd be x to the 4th divided by 5. Okay, now that we got a single logarithm on the same side and it's the same base, we can drop that out. Now we just have a little algebra problem here to solve to get our answer. Times both sides by 5. And if we do that, those 5's cancel out. So now we got x to the 4th power equals, that's going to be 625. To undo the power of 4, we're going to want to do the 4th root of 625. Okay, we can do 4th roots on the calculator too. We talked about how to do that. We want to select the one that, now there's not a 4th root button, but there's one that you can enter any root in. It's this option number 5 here, but before you select it, you need to put in your root. So we want to do 4, then hit math, select that extra root one, and it should pop the 4 in there for you, and then type in 625. And the 4th root of 625 is 5. So our solution on this one ends up being 5. All right, I want you to try this last one here, see if you can pause the video, try out number 9, see what you get. All right, let's see how you did. Hopefully you did pretty good. There's one here that had a number in front, that first one. So let's write that as an exponent. Okay, now we want to look, can we combine any of these logs together? Yeah, these two on the right side we should be able to combine. Now notice this one's plus though. Don't do division. Plus turns into multiplication. So this one on the right side, it should be log base 7 of 27 times 3. And we know 27 times 3 is the same as 81. Okay, so now we got the same log on both sides. We should be able to drop it out. You got x squared equals 81. If you take the square root, you get plus or minus square root of 81, which is going to equal positive or negative 9. If you look though, if we tried negative 9 in for x, that's not going to work. You can't do logs of negative. So the only answer on this one is 9. You can't use the negative answer because negative won't work with logs. All right, try some of those out on the practice.